Okay, welcome. My name is Bryce. This is a presentation that I'll be giving later today. It's currently 31st of August 2011. This is my confirmation of candidature presentation being given at James Cook University, which is basically given 6 months into somebody's PhD. So the title of my presentation is there on the screen. Probably doesn't mean too much just yet. Some of these terms will become a little clearer pretty soon, but essentially my research stems from some work going on at the moment in the realm of potential future internet architectures, or ways we might want to architect certain aspects of the internet in the future. And essentially it extends or stems from some work going on in the realm of making storage in the network itself far more intrinsic than it currently is today. So there's a small contingent of pretty well established researchers both from industry and academia that are currently working on this, and there's growing interest in it. And essentially what they're doing is to say, okay, how well would it work if we had a design of the internet that was better suited to today's use cases, specifically of content heavy material. So if we could actually cache content in a very intrinsic way at the network layer at various nodes throughout the network, would that be effective? There's a lot more to it than that, but that's the sort of salient point in terms of my research. So this slide isn't really relevant, but essentially the name, not relevant for the internet presentation at least. This actually refers back to a presentation I previously gave at James Cook University, where I was referring to NDN or name data networking, whereas for this presentation I'll be using the term CCN or content-centric networking. So in terms of the caching architecture of content-centric networking, the idea is actually fairly simple. You've got data coming from some source and you've got users requesting that data. So in this case the data source is the New York Times, and the data is being represented by green in this case in that dot. And then you've got these things that sit between the users and the source of that data. So these would normally be things like routers, but for all intents and purposes they could be any device in the network really. The only requirement is that these are devices that have some kind of storage and are capable of actually caching information. So the way that the content-centric networking works is that a request goes up from a user for the content then flows back down, and note that the data is actually being cached in this instance at this circle which has just turned green. Likewise flows down further, gets cached at this node now which has also turned green, and finally makes its way back down to this user. Now, when a user from one of these different networks comes along, so say for example over here, notice that what happens is when the data actually flows back down, it only has to come from this green node which is at this second level down in the tree. It doesn't have to go all the way up to the top again. So likewise this comes back down and gets cached ultimately at this person as well, down here, and now they have a copy of the data, both for themselves. But what I'm specifically interested in is this, which is, can these people now actually share this data with other people? The primitive of content-centric networking allows you to do this, and this is something that I'll come back to shortly. But what I'm interested in is to say, how effective is this kind of thing, where you actually get this sharing done between mobile users over wireless connections, basically. So the other point about this is that a lot of wireless devices today are mobile, so not only do you get a situation where somebody is able to share the data with people they happen to be in immediate transmission range of at some given point in time, but people also move between networks. So also the situation like this where data actually moves across networks and is able to be infected, if you like. Infected isn't a very good choice of word, but it's fairly expressive. So infected with the data that somebody else has because they're able to retrieve it from them in this sort of fashion. So there's a number of reasons why you might want to do this. The first probably comes down to something to do with performance, which is you might be able to get, say, higher bandwidth or lower latency if you're actually able to retrieve this stuff from other people that are just close by to you. So for example, it might be faster to retrieve it over some kind of ad hoc Wi-Fi setup as opposed to having to go through the internet and have it travel through, potentially across a nation or even cross continent, something like that. So you're likely to get a lot better latency and probably better bandwidth as well. The second reason has to do with the cost, which is to say, imagine that what are currently these blue nodes still that these users are directly connected to. Imagine these are, for example, cellular data towers, and these users are requesting stuff from their mobile phone over the cellular network when they're out of Wi-Fi range, for example. Now that kind of data access is still very expensive, especially compared to more traditional wired approaches. So if you have sort of two options and you're in a situation where you can retrieve something from somebody that's very close by you, they have a copy of what you're after, or alternatively you have to go to your cellular data network, then it'll often be more favorable to get it from somebody very close to you. Thirdly is simply that there's only a limited amount of spectrum, and as we get more and more devices, we essentially get more and more congestion. So if you can actually isolate the transmission of data to fairly short range transmissions, try and get away from using longer range transmissions, then you're no longer congesting as large a space, if you like. So you can get away with having a larger number of devices. I think probably the final thing would also be if you're in a situation where you may not have necessarily constant connectivity to the internet, and you might actually be able to retrieve enough data simply from other people without needing to actually go through the internet at some point in time. So when you and a bunch of other people, for example, aren't specifically connected to the internet, and it's just you and several people sharing data immediately between one another without the infrastructure. So just to sort of clarify why you can't really do this kind of caching, at least not at the network layer under an IP network. So this is what an IP packet essentially looks like, and I've sort of highlighted the salient features of it here. You've got a source address, a destination address, and the actual data. Now, the thing about this is there's no real name or anything attached to it that lets somebody else come along later and say, hey look, I'm after exactly the same thing as this other person was. So this IP packet only really has any meaning for the duration of a single connection. There's nothing really attached to it, or there's no real semantics around it that let anybody express that they're after this given piece of data at some later point in time. So you can, and it is done, that people do caching at the application layer for things like HTTP, for example. But when it comes down to having some kind of unified solution that actually operates across multiple protocols and is sort of intrinsic to the network, there's nothing really built into IP for that at the moment. So content-centric networking, these are the two packet formats in content-centric networking. So you've got interest packets and you've got data packets. So the idea of an interest packet is that this is what gets sent out to the network from a device that's interested in something. So this actually has a content name in it now. So this is just semantics, if you like, of actually naming a piece of content. Now what comes back is this data packet, which is something which again has the corresponding content name, which will be the same as the name in the interest. But it's also got this data associated with it. So now you've actually got this sort of correspondence where you can say, okay, this content name corresponds to this data. If you were to cache this at some device in the network and somebody else comes along, that person comes along and says, look, I'm interested in this piece of content name. You say, look, I've got that content name in my cache, I can provide that to you. So that gets over the problem of naming. The other nice feature about CCN is that you've actually got a signature of the data itself. So this is a signature that binds the name to the data. Excuse me. So this is what gives you the reassurance that you can actually retrieve data from people that you don't necessarily trust, and you can still verify for yourself that it hasn't been tampered with. So these are sort of the underlying features that really sort of in some respects motivate my research, or at least provide the necessary framework to sort of do this research in and have some general underlying assumptions, such as data being secure and being able to be cached at the packet level on devices that you don't necessarily trust, and you're still able to retrieve it and trust that hasn't been altered. So again, just as a comparison's sake, here's two examples, an IP packet first and then a CCN packet. Very simplified, of course, but in the IP packet you see you've got a source address, a destination address, and then some data. Whereas in the CCN packet you've got the name of some piece of data or some piece of content, you've then got the data itself, and you've got this signature which then binds that name to that data. So getting back to the title of my presentation, it had that word MADNet in there. So let's start out with what a MANET is first. So a MANET is simply a mobile ad hoc network. This comes up in the literature a lot. It's a pretty well-known term in networking, and essentially all it is this really. It's just a bunch of wireless mobile devices that are communicating between one another without any infrastructure. So it's sort of self-configuring. These devices are able to exchange information between one another, and there's no fixed infrastructure. Now, my presentation title actually said internet-based MADNet, so let's put in the internet-based part. So the internet-based part is simply this. It's saying, okay, well, we take a MANET and then we attach the internet to it essentially. So one or more devices in the MANET has access to the internet, and by virtue of this, other devices can also get access to the internet. So then, how do we go from a MANET to a MADNet? Well, a MADNet is simply a mobile ad hoc network with dissemination chucked in there. So using the principles of CCN. And this is a term you won't see in the literature, and that's because it's one that I've just made up. Because if there's any field that needs more acronyms, I think you can agree there's definitely ours. So you can thank me later for that one. So, okay, now internet-based MADNet. So just as a concretion of this now, this is essentially the idea. So one of these wireless devices wants a copy of this cat picture that's on the internet. So the picture first gets transferred to this device. Notice now that it's actually being cached at that device. So now if somebody else wants it, it doesn't come from the internet anymore. It comes directly from that device that previously got the copy. Likewise, now if the laptop wants a copy of that photo, it can actually get it not just from one of those devices, but from multiple those devices simultaneously. And I've just shown this really to highlight that CCN does its caching at the packet level, so it doesn't do it at the object level, and because it does it at the packet level, you can actually retrieve stuff from multiple different devices simultaneously, or multiple different sources. So what are my sort of research questions surrounding this? Well, the first research question is this. If we were to actually overlay one of these internet-based MADNets on top of existing networks, how far could we go in actually reducing our reliance on fixed infrastructure? So how much of the content that's flowing through real-life networks could actually be served or shared between one of these internet-based MADNets without having to go back to the internet, assuming we have this packet caching primitive and it's all secure and the likes. So this is really the ideal case